Hello guys, welcome to my channel. If you clicked on this, I guess you are very curious about AI, especially because of the title, which is what I'm going to be talking about today. And I'm going to be looking at what Databricks have called the big book of AI. I'm going to be talking about the book. All you need to know, all of the steps that they've laid out on how you can use it to get from nothing to start working with AI very well. There's a recent MIT Tech review that report that about 71% of CIOs the plan to build custom large language models. And the reason is very simple. The difference between that generic chatbot and a carefully trained AI is very huge, and it can be as much difference as, and now I'm explaining within an enterprise framework, it could be as much difference as you having your customers and actually losing them. Because if we're going to go into this AI space, which is something that looks like what we are going to go into eventually, you need to understand how not just to create a new chatbot or any of that, but essentially how do you get value from all of the data that you have, and how do you deploy different models into this data to be able to get value. Databricks were great to have laid out an easy to follow 5-stage roadmap in this publication that they did, which I got the email. And it could be helpful to think of this like a series of stepping stones that could guide you from asking the question of what is AI to now thinking, oh, I'm actually running this thing at scale. And if you're watching this on the video, I have this picture that I've put up that kind of explains how this building blocks go. It starts from the very step 0. It goes to your prompt engineering, which is step 1, comes to your RAG, retrieval augmented generation, step 2, step 3, step 4, until you get to 5. I'm just going to go straight to it. Before starting anything or even building anything, first of all, you need to talk about the foundation models, because the foundation models is the base. It's where everything starts from. And that is why this is the level 0, the stage 0. Picture building a house. You need a rock solid foundation, something that is very strong, that's able to hold the weight of your building. But in AI terms, that's what foundation models are. They are large scale pre-trained networks that can handle tasks like code generation, language translation, and answering questions with ease without any problem. Before you can say you want to build any kind of production quality generative AI applications, you need to first of all handle the base models, the base language models you'll be using as the foundation for the layers of more complex techniques. When you decide to do that, it's important to note that while underlying architectures may differ drastically, foundation models generally fall under 2 broad categories. If you want to choose a model, you're either going for a proprietary model like ChatGPT, Gemini, or any of the proprietary model that you have. Or you go for an open source model like Llama, Grok, or DBRX. And I'm going to be explaining DBRX in a short while because that is the model by Databricks. And because most of my talking point is around the book, and I'm going to be explaining that in a short while. So Databricks' own DBRX is one of these foundational models, and it's open source. And if it helps, I'm going to be attaching the link where you can go see the list of all of the open source models that are available. However, if you are curious, if you want to learn about DBRX, because Databricks has described it in the book to be very good, and I was quite shocked when I saw the chart on how it performed in language programming and math, and they've described it as one of those models that is able to rival many of the open source models, which is quite good because you can see it side by side, Llama, Mixtral, and Grok. In fact, when I checked, I found out that it's already been in use by some businesses looking for open source solutions that can give them more control over data rather than sending their entire data to a third party to kind of use their model over their data. Nobody wants to do that. Nobody wants to send their entire data stack to a third party. It's quite a scary thing for business executives. So what they try to do is to look for an open source model, use the open source model within the data stack that they have already, rather than trying to push their data off to a third party. So businesses like software firms, marketing agencies, and even healthcare organizations, they are they're quickly adopting the DBRX right now to speed up everything from customer service chatbots to medical research analytics. The mixture of expert architecture in DBRX is a standout because it tries to split tasks between the expert subnet and giving you faster, more accurate responses in areas like code, math, and specialized domain language. And I know you might be wondering, well, if I want access to this, how do I get started with DBRX? Databricks has kind of made it very, very straightforward. You can just go and download the model directly, or you could go to open source repositories like Hugging Face, and you can download that and other models that are available. But there's a direct link to be able to download it from Databricks directly, and I'm going to have that in the description for this talk. And afterwards, you can use Databricks integrated environment, which streamlines all of the deployment that you could do. And if you want to fine tune, you could fine tune DBRX for your specific task. Fine tuning is an interesting part of AI when dealing with AI, and I'm going to be explaining fine tuning at a later point in this video. And when you have managed the foundational part, you've decided on what model to go for, the next stage is the prompt engineering. Prompt engineering has also become a buzzword, and it's quite hard to understand what it actually means because different people have different ways they've described it. You might already know the meaning, and it's nothing novel. Prompt engineering is essentially the art of just asking the right questions to get the best answers from an AI model. Everybody asks questions, but the right prompt is what actually gives the right response or the most accurate response as you would want. Just think about this. If you go to Google, have you ever typed a question into Google and you end up going through different irrelevant things? You see sponsored ads, you see irrelevant articles or stuff, you just see all of that. And you're trying so much to avoid that when it comes to large language model. If your prompt is well structured, it can get the best output from your AI model. So for instance, if you run a local bakery, there are a couple of ways you might want to ask questions that are going to help you to get more sales in your bakery. You could ask, what do people think about my croissants? Well, if you ask a question like that, that might give you a decent answer, but it's going to be a totally different response that you would get if you ask the question this way. Summarize the top 3 compliments and top 3 complaints about our chocolate croissant from the past 2 weeks online review. And if you ask the question like this, you will get a laser focused insight, and the model knows that it's not going to kind of give you a more generic answer. It's going to drill down and is going to be more niche in its answering. And that could help you to really expand so much in the answer it provides to you. And that is where prompt engineering comes into play. Being able to ask the right question can help you get the best response from an AI model. So the extra detail in your prompt helps the AI serve up actionable results. But let's just go further from that. When it comes to Databricks, Databricks has used prompt engineering extensively. I don't know if you've heard about the Dolly project. It was one of their earlier open source LLMs. The project is to ensure more accurate and context-aware answers for tasks like summarizing technical blog posts or responding to developer FAQs. One publicly discussed example involves using Dolly to summarize a Databricks blog post with a system level directive. So they try to kind of compare the prompt and see which one does better. A prompt could be like, one of the prompts could be, you are a precise technical writer, followed by the full blog text. This guiding prompt reduced irrelevant details and yielded a concise high-level summary. So instead of telling the AI model, look at this blog, try to make this blog better for me, it gave an answer, and it was It was quite more detailed when the prompt started with, "You are a precise technical writer." Just that little extra detail helped the AI to perform better in the response that it produced. There's another experiment that was focused on responding to frequently asked questions about Databricks runtime and cluster configurations. For instance, you might give Dolly a directive like, "You are an expert in Databricks runtime and cluster configurations," and then ask, "Explain how to choose between standard and high concurrency clusters for a small data engineering team." Because you've specified the role and expert and the exact question, Dolly tried to return more accurate and technically relevant answers with very, very minimal back and forth. What's the point I'm trying to make? The point I'm trying to make is whether you're just trying to think how with Dolly, DBRX, or just any AI model, ChatGPT, OpenAI models, remember this. A refined prompt can save you hours of back and forth and yield much more reliable results. In many ways, it's the easiest yet most powerful lever you can pull when working with AI. And when you've managed the state zero, the foundation model, and you go through the prompt engineering, the state two is the retrieval augmented generation, or you call RAG. RAG is essentially bringing info on demand. And the best way I can explain it is that it's the process of you trying to optimize the output of an LLM so it references an authoritative knowledge base beyond its training dataset. So there's an initial dataset for which the model was built on, but you go beyond that and expose the model to a different dataset. And the essence of doing that is so that the model can also make reference to this other dataset in the kind of responses it provides. And that is the gist of RAG. I'm not going to go into the technical part. There are a lot of technical processes when you want to set up a RAG, but on the basic level, that is what it is. It's just think of it like you giving your AI model a personal library card and you say to it, "Well, you have access to this set of books now. Before you used to have access to this very limited set of materials. I can now give you access to much more materials to go do what you want to do, read all of these materials and add this to your learning data set." Usually, a large language model relies on the information in its training data, which might be out of date or incomplete. And I know you might have seen that you try to ask ChatGPT a question and it tells you that the knowledge it has, the cutoff date was 2023, and you say, "Okay, but I need something in 2024. How do I get that?" And these models have cutoff dates for which they were trained, and you might want to ask more questions beyond that. And that is where RAG comes into place. And RAG connects your AI to specific real-time data sources like your sales database or customer support logs. It lets you bring supplemental knowledge resources to make an off-the-shelf AI system smarter. So you might be asking, "David, give me an example of this." A good example is, let's say you are running an e-commerce site and a customer asks you, "Where's my recent order?" With RAG, your customer service chatbot can instantly grab details from the shipping database. And the chatbot is just a different LLM, but now you can expose it to your shipping database, and the chatbot can go to that shipping database and give the exact status of the customer's question, which is about the current order. In contrast to a regular model, it might just give a generic answer. We are working on it. But when you expose the LLM to your entire database, you're actually trying to leverage the retrieval augmented generation, where it can now go to an external database and do something with it. You might be interested in exploring this more. You can check out frameworks such as the LangChain, you have Haystack, and even the Databricks blog. Just search for LLM on retrieval augmented post when you go to Databricks blog. I'm going to leave a link to this in the description, and when you come, you can just search for this, and the link to this is going to be on the description for you to just play around, and you can get details on guides on building retrieval augmented systems. Also found this very good article on retrieval augmented system, and I'm also going to put this in the chat for you to just go through it. An additional resource was a real life example I read on the application of RAG by Morgan Stanley. And so Morgan Stanley tried to integrate GPT-4 into their proprietary data repositories. What this setup did was that it allowed financial advisors to quickly retrieve and reference up to date market research reports, product details, and compliance manuals all within a single interface. You don't need to go out and try to scan through different documents and different repositories. And as a result, they can provide more accurate and real time tailored recommendations to clients without having to navigate multiple documents or systems. Well, that's enough for RAG. So let's go to stage 3. Stage 3, I promise I'm going to be talking about fine tuning, and here we are. Fine tuning foundation models. It's your custom AI tailor. What a tailor does is what fine tuning does, really. Maybe you can just picture this. You just bought a nice suit or dress off the rack. It's good, but it doesn't fit perfectly. Fine tuning is like the tailor that helps in bringing it to shape. And just like a tailor, fine tuning is essentially training a pre-trained model again on a new data to focus on a specific demand or skill. Like, I use the example of the tailor very, very deliberately because the tailor is not sewing the clothes all over again, it's just making adjustments. And that is what fine tuning does. It makes the AI model accurate and specialized than a general model. You start with generic foundation model like the DBRX or GPT 3.5, GPT 4.5, GPT 4, or whatever model you want to use. Then you train it on your specific data to get customized solution. As an example, you might have thousands of product reviews or industry specific manuals within your organization. By fine-tuning your model on that data, it becomes an expert in your domain. Databricks describes a real scenario where two engineers built a fine-tuned model under a month. It was dedicated to automatically writing database documentation. The results were faster content generation, lower operational cost, and fewer errors than a more generic model. Instead of RAG just exposes the model to your database, but fine-tuning, you try to retrain the model and kind of add more to the training materials of the model, which can shape the behavior of the model in the long run. A lot of companies use this approach for tasks like customer service. They training the AI on internal support knowledge bases, like retraining, not just exposing the model to this data. They also use it for legal contract analysis, trying to feed the AI past contracts so it understands the specific language of that industry and how the industry, the organization, or what have you, how they respond and draft legal documents. And you also have financial forecasting, training on proprietary market data for up-to-date predictions, which I have given an example of a real-time project that was done, but that was in the case of RAG. But you could go beyond that to actually training the model with this proprietary data you have. And when you are done with fine-tuning, the stage 4 is where we come to the more complicated part, which is the pre-training. If fine-tuning is tailoring, like the anecdote I'm using, pre-training is actually designing from scratch. Now you're not making an adjustment on the clothes, you are giving a plain material to actually make a suit from it. Pre-training is the process of training an AI model from scratch on a large general data set that it can learn core patterns or language structures. This foundation is later refined for specific tasks or domains in fine-tuning. Pre-training is the most advanced step in all of the steps I've described. It's at the peak because it involves gathering your own massive data set, often terabytes of text or structured data, and building your AI model from the ground up. And among the things you do, you clearly shape how it learns patterns, language, or even images. Yes, it's time consuming, and I've said it before, because it takes a lot of time and it's very expensive. You need to have engineers, you need to have data, you need to have it AI ready, you need to have the expertise, the people that actually know how to do this. It's more expensive, but it also gives you complete control over your AI's capabilities and knowledge. Control in this context is very important, and I'm going to explain. First, you are not relying on someone else's pre-trained model architecture. domain knowledge, or data. You decide the exact scope of text, images, or other signals your model sees during training. For highly specialized tasks like drug discovery, advanced medical imaging, or hyper personalized recommendation systems, this precision can make all of the difference. Well, for an example, I have an example that was done by Databricks. And when Databricks made wave by training Stable Diffusion, it was a model that generates text from text input from scratch for just a little bit under $50,000, which was great and at the time was really unthinkable. They managed this by carefully curating data, optimizing their compute usage, and using the Databricks Lakehouse platform scalable infrastructure, which is something they already have. In practical terms, if you go the pre-training route, you'll likely need one, a robust data governance plan, since you will put data from multiple sources. There needs to be some data governance in place. Who owns the data? Who is responsible for the data? What are the processes for getting this data? Who handles the legal part of this data? A number of things that are not even technical, which are some of the hurdles you're going to encounter. The second one is access to significant compute resources. Think GPU clusters or cloud-based HPC environment. And the third is the expertise, which is what I mentioned initially, is that you need expertise in data processing pipelines so you feed very high quality data well curated into the model. Well, because pre-training is a hefty investment, nobody wants to consider it. And many businesses they run away from it. They only consider it when the payoff is equally big. And I'm going to come to the final one, which is the LLM evaluation. It's really checkups to keep up with your track. Yeah, I know when I mentioned the word evaluation, checkups, if you are a software engineer or just a product manager, someone that have managed products, managed software, managed code, you know that evaluation and checkups is nothing new. If you deploy a code, you regularly try to check it up because things break. And you just need to ensure the health of the product. As a matter of fact, maintenance takes a huge chunk of budget when deploying a new product or a new code. And LLM is no different. Because if you have a website, for instance, that loads super slowly or breaks randomly, you know the importance of regular testing and maintenance. LLM evaluation is really the process of trying to measure how well the large language model performs across tasks, and you are able to use different tools to judge the accuracy, coherence, and how useful this model is for the people that are using it. What it does for developers is that it helps them to ensure that the model meets quality standards and fulfills user needs. In Databricks world, they talk about tools like Databricks Gauntlet, essentially a series of tests to see how well your model performs. I've mentioned Hugging Face Leadership Board. They also try to rank AI models based on many tasks, so you can track how your model stacks up based on different metrics that they use and parameters. So it's a good way to measure your model and the effectiveness and accuracy. Companies often schedule weekly or monthly eval runs to also check for a couple of things. The first is that they could be looking out for accuracy and helpfulness of responses. And secondly, they could be checking for the speed and scalability because nobody wants a large language model to use 3 hours to respond to how are you. And they also check for gaps in knowledge. Where is this large language model having different gaps in knowledge? And they have different ways of testing for this. And because AI models, they are not static, they learn and adapt. This continuous evaluation ensures you are always putting your best foot forward. Well, after saying all the things I've talked about, and I'm going to just tie it up together. How do I get started? If you're new to generative AI, which is quite funny because we all are new to it, here's a quick start list for you. First is pick a foundation model. Check out open source options like DBRX or just anyone, or go with a popular model from a vendor. Secondly, practice prompt engineering. Tweak your prompt and see how the AI's output changes. The third one is explore RAG, which I've talked about extensively. Decide which data sources matter most for your business. Maybe it's your CRM or live inventory data, shipping data, or demand data, whatever data you have. Just decide which of them matter most to you If needed, start small by fine tuning on a few thousand data samples. You track the improvement and see how that goes. And the final one is trying to do evaluation often. Benchmark your result, fix what's not working, and it's a loop. You repeat. In the end, remember generative AI is a tool, it's not magic. But it can unlock tremendous value from automating day to day tasks to creating new revenue streams if used wisely. I really enjoy the position of thought leaders, and one of them is Andrew Ng. He often talks about AI's real power to be in bridging the gap between big ideas and practical solutions. And you could check that out, and I'm going to leave a link to this as well. You could just read his thought and see what other thought leaders are saying about generative AI and what it can do. So take note of these 5 stages. Try to adapt them to your business and don't be afraid to experiment. You will learn the most by trying different approaches and measuring outcomes. Before you know it, you'll have a generative AI system that feels like a natural extension of your team, helping you and the business thrive in an increasingly AI driven world. Until next time, thanks for listening. If you've not subscribed, please do subscribe to help me continue with this, and subscribe from wherever you're listening from. And I'm going to see you in my next video and podcast release. Stay tuned. Bye for now.